So we proved that g prime is f. So that's another way of saying if I take the derivative of this, that let's just kind of think about what this means. The integral and the derivative cancel, and I just put the x into the function. Oops, I'm sorry, g prime. When I've taken the derivative of this, I cancel the integral, and I just get the function with the x plugged in. Okay, so another way of saying this, find the derivative, and this could be written, find the derivative, right? 1 to x of t to the fourth dt. So you can think of the derivative and the integral canceling, and I just put the x into the function. This one's not quite ready because it doesn't have the x in the top limit of integration. Oh, but we remember that property. I can switch the limits of integration, and then I'll get 2 to x, and then I'll carry this 4 minus t squared dt along. And then I'm going to carry the negative sign along, right? And then I'm going to cancel the derivative and the integral, and I just put x into the function. Okay, let's look at this next one. Make it a little bigger. Take the derivative of this. Look at that. I've got a function that I'm going to be plugging in. Now, since I'm taking derivative, chain rule applies. Okay, so what that will look like. So taking the derivative, I'm canceling the integral, and I'm putting x cubed in everywhere there's a t. So I'd have x cubed cosine of x cubed, and I carried that x cubed along. So to finish the derivative, I'd multiply by the derivative of x cubed, which is 3x squared. So this one here, I'm going to say I want to take the derivative, but I see the x terms down in the bottom limit of integration. So I'm going to move it up top. Okay, and now I can cancel the derivative and the integral, and whoops, don't forget my negative. I'm going to substitute e to the x in everywhere there's a t. And then I'm going to multiply by the derivative of e to the x, which is e to the x, and that's me doing chain rule. Okay, so in the other video I showed you with a proof of this. Okay, so let's just do it. So let's start with the antiderivative. So that's x cubed over 3, make that neater, plus 5x squared over 2. Remember, we don't put plus c. Then I'm going to plug in x equals 3. So I get 27 over 3 plus 5 halves times 9. And then I'm going to subtract off, plugging in x equals 0. Well, that's just 0. So this will give me 9 plus 45 halves. And that's the exact area under the curve. Okay, so this one here, x cubed over 3. Remember, find the antiderivative, 3x squared over 2. And then from 1 to 3. So this one's got 2 numbers to plug in. So remember, you always plug in the top number first. So 27 over 3 plus 3 halves, and then I'm just going to put times 9. And now I'm going to subtract off, plugging in the 1. So I get 1/3 plus 3 halves. So you're just going to get ugly numbers. That just is what it is. You can simplify a little bit, but yeah, just is. All right, so now let's look at details. So you're remembering antiderivatives. So I have to have x to a power in order to add one, right? So if it's x to the n, the antiderivative is x to the n plus 1 over n plus 1, right? So I need to separate this radical around the 2 terms that are inside there. So I'm going to have plus root 3, and then I'm going to rewrite it even as x to the 1/2, so that in the next step, I can increase its exponent, right? Add 1. Integral increase exponents. So let's see, this will give us e to the x, antiderivative of e to the x is e to the x. Carry the root 3 along, and then I would get x to the 3/2 over 3/2, and I'll just go slow, 0 to 4, and then I'm going to rewrite that, e to the x, and then be plus 2 over 3 root 3 x to the 3/2. Okay, so then I still have this. So you always carry this along until you actually go do the plugging in. So if I plug in x equal 4, right, I get e to the 4 plus 2 root 3 over 3. And you know that, let me just write it here, 4 to the 3/2 power. So I would be taking the square root of 4, which is 2, and cubing it, and that would give me an 8. Minus, so be careful with that 0. The 0, e to the 0 gives me 1, right? And if I put 0 in there, that's all there is. So this would be the answer, right? Big ugly things, you're just expecting ugly things. All right, so let's look at this next one. So you're thinking integral antiderivative, right? So I want to take, what can I take the derivative of to get secant squared? Oh, that's tangent, right? So I get tangent, and so this one was x's, right? This one's t's. So I'm going to keep the letters the same. And then I'm going to plug in pi over 4, subtract off, plugging in 0, so that gives me 1. This one I want you to be careful with. So I must pull that 1/2 out or off to the side before I can do the antiderivative. Then I get ln of u, right? And don't forget those absolute values. And then I plug in 5, so that gives me ln of 5. And you can throw away the absolute values once you see it's positive. And you know ln of 1 is 0, right? Don't forget that. Ln of 1 is 0, so I'm just not even going to write it down. Okay, so the antiderivative of 4 to the x is 4 to the x over ln of 4, and then between 0 and 2. So plug the 2 in first, subtract off plugging in the 0. Okay, let's think about this. This is 16 over ln of 4 minus 1 over ln of 4. That's the same thing as saying 15 over ln of 4. Just pointing that out because I'd probably simplify like that in my answer. This one here, I need to rewrite that e to the t over 2. So e to the t plus 2. E to the t plus 2 is like saying e to the t times e squared, right? Because you add exponents when they multiply and they have the same base. So it's necessary to break that up because I only know the antiderivative of e to the t, not e to the t plus 2. We'll get into more complicated antiderivatives in a short period of time, but for now, let's just rewrite this. So this would give me e to the t times e squared, and then carry along all the stuff, and then I can pull e squared outside, negative 1 to 1 e to the t dt, because e squared's just a number. And now I'm going to take the antiderivative of e to the t. It's e to the t. So notice when I take the antiderivative, let me break it on the next line. Carry that thing along, e to the t. So when I take the antiderivative, this and the integral sign go away, and that's when I put the from negative 1 to 1 thing, right? So I get e squared times e to the 1 minus e squared times e to the negative 1. So there it is, it just is. So this would be e cubed, and then minus e squared over e, right? So e cubed minus e, if you wanted to simplify that.